Assalamu alaikum, dear students. Mr. Atik is here from the science department once again. Today I prepared a lesson regarding chemistry subject for grade 12 for you guys, and the stuff for this week is chapter 22 section 2. We will study about the hydrocarbons. The pages we are going to cover in this week are from 674 to 676, 674 to 676. Let's start from the preview of this chapter. What are the main objectives, the main ideas regarding hydrocarbons, alkanes, kinds of hydrocarbons, cycloalkanes like the benzene structures, alkanes, systematic names of alkanes, who give the name, which systems are just following, and which system implements usually like the alkane names, who given them the name, properties and uses of alkanes and unsaturated hydrocarbons. In the objectives, look at, we have to distinguish among the structure of alkanes, alkenes, alkynes. Now look at just the name, consider the names A in E. A in E here for the alkenes, E N E, and for the alkynes Y N E. Are you getting my point? And aromatic hydrocarbons. Look at the A in E phenomena, E N E and Y N E. Is there any difference? Yes. We have a difference for A in E, like single bonds. Hydrocarbons contain single bonds or consist of single bonds. E in E like double bonds, and Y in E like triple bonds. Okay, you can consider alkanes like hydrogen, but as it is hydrocarbon, it means what? Hydrogen must be there and C must be there, like the carbon must be there. Hydrocarbons. Getting the idea? Hydrocarbons, like carbon will be considered as the backbone as we studied for the organic one, but here we will include what? The hydro as well, like the hydrogen. So whenever the hydrogen and the carbon has a single bond, so we will give them the name alkanes. Whenever it has like double bonds, we will give them a name alkenes, E-N-E-S. And whenever it has like triple bond, we can call them wines. Okay, alkynes. Got the ideas? Okay, write structure formula as a name for the alkanes, alkenes and alkynes respectively, as I told you. Relate properties of different types of hydrocarbons to their structures, like how the structure being changed, how it can be changed, and how due to the structure changeability, what are the properties they are going to be in consideration to be disturbed, okay, or to changed. Now look here, hydrocarbons. Hydrocarbons are compounds that contains only carbon and hydrogen, as I told you, as I mentioned before. They make up the simplest class of organic compounds. This is obvious, it's okay. All other organic compounds can be viewed as hydrocarbons in which one or more hydrogen atoms have been replaced by other atoms or other groups of atoms. Well, nice. Saturated hydrocarbons. These are the types of hydrocarbons. Saturated hydrocarbons. These are hydrocarbons in which each carbon atoms in the molecule forms 4 single covalent bonds with other atoms. 4 single covalent bonds. Imagine 4. Come to the alkanes. Alkanes, A in E-S. Hydrocarbons that contains only single bond, as I mentioned before. Hydrocarbons that contains only single bonds are known to be alkanes. Straight chain alkanes, straight chain. Okay, it make a kind of roof, a straight roof. Straight chain alkanes differ from one another by 1 carbon atoms and 2 hydrogen atoms. A bond CH2 bond again. It will be known as what? Alkanes. Alkanes, A in E is why I am mentioning A in E again and again. A in E concept means what? Like a single bond. Let me title for you. Let me title this thing for you like single bonds. single bond concept. Are you getting the idea? Alkanes, A in E concept, like single bond concept. Look at the previous slide. Hydrocarbons that contains only single bond. Look at this one, single bond. So here, single bond concept. A homologous series is one in which adjacent members differ by a constant unit. Okay. A general molecular formula can be used to determine the formulas of all members of a homologous series. It's okay. In the homologous series of a straight change alkanes, the formula for each compound is determined by the general formula CnH2n plus 2. Cn, the number of, this n indicates what? The number of what? Hydrocarbon. Number of carbons. Now H2n, H2, hydrogen. This is the number of hydrogens plus 2 for the single bond concept. Look at, consider a single formula now for the ethane. Ethane, A in E, C2H6 is the formula for the ethane. Now look at, N is the number of 2, like carbon. So there are 2 carbon atoms. Look at, as I told you here, that Cn, known as what? Like the carbon atoms. So there are 2 carbon atoms and 2 cross 2 plus 2, 6 hydrogen atoms. Like here, H2n. This 2 will multiply with this n. And then plus we will add like 2. So it will give us what? The 6 hydrogen atoms. And its formula is what? That's why C2H6 can occur. Okay? Or arise, you can say. For propane, A in E again, CH3. Like we have, look at, we have methane, ethane, propane, butane, pentane, hexane, heptane, like 7, octane, nonane, and decane. Understand? A in E, all will be entitled with A in E. Again, similarly, N is equal to 3, like the number of 3 carbon atoms, and 2 cross 3 plus 2, 8 hydrogen atoms. And its formula is what? C3H8. Cycloalkane. Cyclo, look at the names indicates like cycle one. Like what the benzene structure one. Got the idea? Like it will be like a curved shape, you can say, or a ring structure here. Cycloalkanes are alkanes in which 1 carbon atoms are arranged in a ring shape. Look at cyclic structure. The structure formula for cycloalkanes are often drawn in simplified form. It is mentioned in the book. If you open up the book, you will see there. Understand? Cycloalkanes. In skeletal presentations, it is understood that there is a carbon atom at each corner and enough hydrogen atoms to complete the 4 bonds to each hydrogen atoms. Now cycloalkanes. Look at the formula for this thing. The general formula for cycloalkanes, CnH2n, there is no plus 2. Why? Because this is cycle or a ring shape here. Show that have 2 N hydrogen atoms and 2 fewer hydrogen atoms than non-cyclic alkanes. Non-cyclic alkanes are what? Like the common alkanes, CnH2n plus 2 have. Cycloalkanes have no free bonds, remember, or no ends, you can say. Sorry, have no free ends. Where a carbon atoms is attached to 3 carbon atoms, of course. It is a ring shaped. Now systematic names of alkanes, who give them the name? How the unbranched chain alkane nomenclature occurs or arises. Now look at. To name an unbranched alkanes, use the prefix that corresponds to the number of carbon atoms in the chain of the hydrocarbons and add the suffix A in E. Why I am emphasizing on this phenomena only? You need to remember different kinds of hydrocarbons entitled or look at their names so you can clearly assume. The A in E concept is for the single one. E in E concept is for the double bonds. And Y in E for the triple bonds. Let me draw for you guys here. Or let me just include this thing. A in E. Single bond. Now E in E. Double bond. YNE triple bond, triple bonds. All the bonds are covalent in nature. Okay, look at the names only. A in E single bonded one, E in E double bonds, Y in E triple bonds. Like consider ethane, ethene, ethine. Look at here, A in E, E in E, Y in E, ethine. Now it is clear, I think, yes? Now, systematic names of alkanes. Historically, the names of many organic compounds were derived from the source in which they were found. Look at the source, okay? A systematic naming method for organic compounds became necessary because of the many organic compounds that are possible. A systematic method has been developed by the International Union of Pure and Applied Chemistry, IUPAC. The abbreviation of IUPAC is what? This is just going to the bold nature as well. Anyhow, International Union of Pure and Applied Chemistry. This is an international naming system, okay, to name organic compounds. So from the IUPAC they give them the name alkanes, okay. Using these systematic names, you can tell what the structure of an organic compound is by looking at its name. As I mentioned clearly, I think this is the most interesting lecture that we got, and this is a bit clear idea. You need to get this clear idea regarding these things. A in E single bonded, Y in E, like just look at the name, focus on the name, so you can just predict it, how many bonds will be there. And remember, all of the bonds here, look at, as I mentioned here for you guys, let me again, all the bonds are covalent in nature amongst these hydrocarbons or organic compounds. Okay, this was today's lecture. We will continue to study these things as well, some properties of alkanes then as well, and we have interesting setup to come as well, like for in the shape of alkenes and alkynes as well. Okay, see you then, fi aman Allah.